In this video, we're going to take a look at solving systems of equations by substitution. We can recognize when we want to use substitution because at least one of the equations will already have a variable solved for it. So it'll be x equals or y equals, and we'll get to example number 4 at the end at how we can use substitution when that's not the case. In example number 1, y is equal to negative 3 minus x. I'm going to take that and I'm going to put it in the y place because that's what it's equal to. So 3x plus y, instead of writing y, I'm going to put in parentheses what y was equal to in the first equation, and then finish it off equals 3. I'm going to solve this equation and get x. What I've accomplished now is going from two equations with two different variables down to one equation with only one variable, which I can easily solve. So you can do that on your own, and again, feel free to work ahead in this video if you're feeling confident with substitution. So when I solve this, x equals 3. Hopefully you got that as well. I'm going to take the 3 that I got for x, and I'm going to substitute it back in for the x value in my first equation. I need to do this because I still need to find out what y equals. So y equals negative 3 minus, and instead of writing minus x, I'm going to write minus the 3 because I'm going to replace the x with 3. It's important to get in the habit of replacing variables with values or expressions using parentheses. So y equals negative 6. And for every solution to a system, I should have an ordered pair. So if y equals negative 6 and x equals 3, then my final answer is 3 comma negative 6, or the point 3 negative 6. For my second equation, this time y isn't by itself, but x is. So this time I'm going to replace the 10 plus 2y, what x equals, into the x spot. So again, using parentheses, instead of writing x, I'm going to write 10 plus 2y, and then I'm going to finish the rest of the equation, minus y, and then equals 4. And again, now I have one equation with only one variable. So I'm going to simplify and solve. And y is going to equal negative 6. I'm going to take that value for negative 6 for y, and I'm going to replace y again in my equation that originally had x by itself. I could technically substitute it into either equation, but it'll always be more convenient for me to substitute it in the equation in which the variable was originally isolated. So x is equal to 10 plus 2y, and instead of writing 2y, I'm going to replace the y with a negative 6 and solve. So x is going to equal negative 2. This gives me a final solution of the ordered pair negative 2, negative 6. It's important that we check our work throughout these problems, the benefit especially being that on quizzes and tests, you can guarantee whether your answer is correct. I'm going to do that by replacing the negative 2 for the x and the negative 6 for the y into the second equation, the one that doesn't have the variable isolated. If that gives me 4, then I know that my original point is correct. And in this case, -2 minus -6 does give me 4. So this is my final and correct answer. In number 3, y is by itself. So I'm going to put -3x into the y spot into my second equation. So x minus, again using parentheses, -3x in place of the y will equal 4. And solving this, I get x to equal 1. I'm going to substitute that 1 for the x variable into my original equation that had y isolated. And so y is going to equal -3 times x, but instead of x, I'm going to put 1. So y equals -3. That gives me a final answer of 1, -3 for my ordered pair or my point of intersection for these two linear equations. Again, if I check, 1 minus a -3 does give me 4, so I'm guaranteed that this is the correct answer. In problem number 5, I don't have a variable by itself. Most often we'll use a different method for these types of problems, but in this case I could easily get y by itself by subtracting 2x from both sides, and therefore rewriting that second equation as y equals -2x plus 6. Technically, I could have easily rewritten the first equation as well. It wouldn't have mattered. I'm going to now take the -2x plus 6, what y equals, since y is isolated and by itself. I'm going to take that expression, -2x plus 6, and I'm going to substitute it into the y value in my first equation. So that gives me 3x minus, and then in parentheses, and the parentheses are important, -2x plus 6. And that equals 9. So I'm going to distribute. I have to distribute that negative, which is a -1. I'm going to do -1 times -2x and -1 times 6 to give me 3x plus 2x minus 6 equals 9. So again, solving in this particular equation, I end up with x equals 3. And I'm going to replace the x variable with a 3 into one of my two equations. And it really doesn't matter which one. Okay, so I'm going to choose to use the one where y was solved already. So I'm going to replace that x value with 3. So y equals -2 times 3 plus 6, which in this case ends up giving us 0. So I have an x coordinate of 3 and a y coordinate of 0. So my answer, or my point of intersection, is the ordered pair 3, 0. In summary, for substitution, you're identifying one of the equations that has the variable already isolated. You're substituting that expression for that variable into the other equation, solving, and then substituting that answer into an equation to get the second variable.